Hi, welcome back to PSLE Math Heuristics lesson. Now, today we are going to continue with our part 4 on model drawing, before and after model drawing. So let's look at the homework that you're supposed to do, right, for the last lesson. So we went through some examples on how to draw the before and after model, and so we are going to look at a few more questions. Okay, now Victoria brought twice as much money as Dora. So when you see this sentence, you have to put down the number 2, right? Victoria brought 2 times as much as Dora, so Dora has 1 time. So after Victoria spent $360 and Dora spent $110, both of them had the same amounts of money left. So there is an equal concept over here. So when there's an equal concept, what do we do in the model drawing? We have a dotted line to show the equal concept. So how much money did Dora have at first? Okay, so in our previous lessons, we talk about we can combine the model drawing together, we can combine the before and after model together, or we can separate them. So you can choose whether you want to combine or you want to separate the 2 models. Each has its own advantages. So if you combine the 2 models together, then you have lesser drawings, but on the other hand, you will find that you will need to look very carefully at what you have drawn because everything is all combined together. So it may not be so easy to see what you are drawing. If you separate the model, then it'll be quite clear to see because you have 2 separate models, so everything becomes clearer, but then it also means that you have to draw a bit more, right? There's more things to draw. Alright, so over here, let's combine them together. Alright, let's see how you combine them. So I'm going to have the before, so let's draw the before model. So Victoria brought twice as much as Dora. So let me just put the Victoria and Dora, and I'm going to draw a long rectangle, and that will be twice or 2 times, and Dora will have 1 time. So when you draw your model, try to draw proportionally and also try to draw big. Alright, don't draw too small, but also don't draw too big, so that you can cut it later. Alright, so you are done with the first sentence. So after Victoria spent $360 and Dora spent $110, so both had the same money left. So the equal concept. So when you have the equal concept, what do? You have a dotted line. So it is not advisable, to use or to cut the model in this way. Now, because if you cut the model in this way, what happened? You will get yourself confused, and you will think that you cut a box into 2 smaller boxes, right? 2 equal smaller boxes, which is quite dangerous because it's not true. So I will not use a dotted line to cut like this. Instead, what do? I will use a dotted line to cut either here, or I can cut either here. Alright, so that I don't get myself confused by thinking that you have cut a box into 2 smaller boxes which are equal. So let's cut the model, right, like this. Okay, like this, for example. So you can see that where is the equal concept? Now the equal concept is over here. They now have equal money left. So both Victoria and Dora had the same money left, which means that how much did Victoria spend? Victoria must have spent $360 and Dora must have spent $110, which is that small little box there. Okay, so that is how you cut it, how you cut when you see equal concept using a dotted line. So how much money did Victoria have at first? So your question mark, right, your question mark will be to find something like this. How much did Victoria have at first, which is the question mark. So where is the after model? Now your after model is combined together with the before model. So your after model will be something over here, which is the remaining money that is left over. So this is the what? This is the remaining money that is left. Okay, the green color box. Okay, the green color boxes that look equal. Alright, so the model is done already. So what do? Now, very simple. There is no total given to you, right? You can see that on the model, there is no total, because if there is a total, then we can add everything inside the model together. But there's no total, so you can't plus. Then what do? You minus. All right. So where's the units? The units are here. So these are your 2 times, and Dora will have one unit. Okay, Dora has 1 unit. Okay, so let me just draw something like that. Okay, all right. So we're going to minus to find the difference. So if you look carefully, you can see that there is a difference of 1 unit, right? 2 unit minus 1 unit. So Victoria has 1 unit more than Dora. And how much is that 1 unit? You compare the whole numbers. All right, the whole numbers is, if you look at $360 and you minus $110, that will give you the difference. So if you cannot plus in the model, then you minus. So you will get $250, which is 1 unit. Okay, so once you know that there is 1 unit already, so can we find how much did Victoria have at first? So Victoria has 2 units, right? 2 units. So 2 units will be 250, and then you times 2. So Victoria must have $500, and that's how you solve the problem with just a few steps. Alright, so if you draw a good model, like what I mentioned before, you don't need a lot of steps to find the answer. So it's only a few steps. So that's how you draw the before and after model when you combine them together, right? Okay, so let's look at another practice example, and hopefully by the end of the lesson today, you have a good idea, all right, good idea on how to draw the before and after model, which is not actually very hard to draw. Okay, practice number 2. Now, there were 880 coins in container A and B. Thereafter, 32 coins were transferred from A to container B. So there is a transfer. So when there is a transfer, then what is unchanged? The total is unchanged. And that concept we need to remember. So every time you transfer from one place to another place internally, right inside the problem, then you have the total unchanged. So container A now has 3 times as many as container B. So how many coins were there in container A at first? Now, if you are going to separate the model, which is also possible, then this is how it will look like. So your before model, container A and container B. Now, do we know how many boxes or how many coins in container A? We are not sure because the question never really says, right? So you can guess, you can assume. Maybe container A has more, maybe container B has more. So we are not sure. So you just anyhow draw. And later on, if you find that you have drawn a little bit wrongly, you can always adjust it. You can always erase. So I'm going to just anyhow guess. Maybe container A has more. But actually, we don't have to anyhow guess, because you look carefully at the question. You take out 32 coins from container A and put into container B, and in the end, container A still has more, right? Still has 3 times as many coins as container B. So that means that container A must have more coins. Why? You take out the coins from container A should become lesser already, but in the end, container A still has more than container B. So that tells you that container A actually has more coins than container B at first. So your model should be something like this. So we don't really need to assume. We don't really need to anyhow draw. But sometimes the question may not tell you which has more or which container has more, and it's not very clear to see. Then what do? Then you will have to assume. You have to just anyhow draw, but later on, if you make a mistake or you think you make a mistake, then you can always undo. You can always erase a drawing, not everything, just erase part of that drawing, and then just draw that part again. Alright, so it's very flexible in your model drawing. Okay, so there were 880 coins in container A and container B. So that is the total at first. And after 32 coins were transferred, so I'm going to cut a little box here, and I'm going to put that little box over this side, which is beside container B. Alright, so you're going to transfer 52 coins from container A and put into container B. So have you transferred already? Have you taken out already? Not really, because the 52 coins is still inside the rectangle for container A. So has container B received already? Also not really, because it's only a dotted box. So container B is going to get the 52 coins, but hasn't gotten yet. Okay, so we are now going to draw the after model. And we are also going to make use of a dotted line. So the dotted line has a few purpose. Like what we see just now, you can use a dotted line to show the equal concept. You can also use a dotted line to show where you are going to draw your rectangle until. Like for example, container A now becomes shorter, so we draw a dotted line downwards. And how do we draw the rectangle for container A, which is until the dotted line? So this dotted line has a second function, is to show you how to draw the rectangle. Where do you draw the rectangle until? And then container B will have a longer rectangle now, and I draw a dotted line downwards, and container B now has a longer rectangle. So that is how you use a dotted line to help you to draw the rectangles. And how many coins? Oh, okay, container A now has 3 times as many. So in the end, container A has 3 times. So if you cannot cut into 3 boxes like this, right? If you look carefully, if you cut into 3 boxes, what happened? Your container B has 1 big box, so it's not proportional. So we can do something different. We can put the 3 units inside 3 times, and we can put the 1 unit inside the boxes. Right? That is another way to label your 3 times and 1 time. Okay, so how many coins were there in container A at first? And your question mark is over here, and you are done. So your model is done already. So in this model drawing, what did we do? We separate the model. But can we put them together as one? Also, we can. But when you put them together as one, then it might be a little bit harder to see what you are drawing. So, but when you separate them, it'll be a bit clearer. But you have to draw more things. Okay, so this is a transfer, right? There's an internal transfer happening. So what is unchanged? The total is still the same, right? And because the total is still the same, what do you see? There's a total there, right? There's a total. So which means that I can add up all the units, which is 4 units, and the total is 880. So what is 1 unit? So 1 unit will be 880 divided by 4. So my 1 unit is 220. Okay, so if 1 unit is 220, I can find how many is 3 unit. I can also find how many is 1 unit, which is in the after model. So my 3 units will be 220 times 3. That will give me 660. And my 1 unit here will be 220, right? But I still haven't got the answer yet. So I can work backwards and put the 660 inside the box here. And what is the question mark? How many coins are there in container A at first? I just take 660 plus the 52, and that will give me how many coins are there in container A at first. So my answer here will be 712, and I solved the problem. Right, so this is how you draw the before and after model. Alright, so we are done with this this part of the model drawing lesson. So we are going to go into part 5 and part 6. So in part 5 and part 6, what will we be looking at? We'll be looking at one group unchanged, right? One group unchanged, the difference unchanged, and everything changes. Alright, one group unchanged and the difference unchanged. So what have we done so far? We have actually looked at total unchanged. We have also looked at everything changes. Like for example, if you look at the previous problem, what is unchanged? If you look at the previous problem, you can see that everything changes because both Victoria and Dora, they spend money. Right, they spend money, and their total have become lesser, and each person's money has become lesser. So in this problem, everything changes, right? But in the other problem that you saw just now, there is a transfer. So when there is a transfer, then the total is unchanged. So in the next lesson, we'll be looking at the difference unchanged, when is the difference unchanged, and when is one group unchanged. Alright, so stay tuned for the next lesson.